Okay, everybody, let's take a quick look at this question here. It says, an object moves in a straight line with velocity v equals 6t minus 3t squared, where v is measured in meters per second. Okay, how far does the object move in the first second? How far does the object move in the first 2 seconds? The object is back where it started when t equals 3. How far did it travel to get there? Okay, so let's take a quick look at these one bit at a time here. And I've got my calculator off to the side here because I suspect I'm going to have to refer back to it. Okay, so we know that velocity is equal to 6t minus 3t squared. Awesome. How far does the object move in the first second? Well, that's a distance question. So what I got to do is I got to take velocity here and I got to go backwards. Now remember, velocity is the derivative of displacement. So now to get displacement, I got to take the antiderivative of this. So I'm going to increase the exponent by 1. So this will be 6t squared over 2. So 3t squared minus 3t cubed over 3, so the 3's will cancel, so t cubed. But there's that arbitrary constant there. Okay, so now that might look like a bit of a dead end at this point, because how am I supposed to figure out what the arbitrary constant is? But the question said, how far did the object move in the first second? Now, in the first second, if you look at the timeline here, okay, bearing in mind that we can't have negative time here, here's 1, here's 2, and so on. The first second is this interval right here, okay, from 0 to 1. So what we want to do here is the distance that it's traveled is going to be the change in displacement, okay, from 1 second. Oh boy. Oh, it's way over here. There he goes. From 1 second back to 0 seconds. So now really all I have to do is evaluate this. So this will be 3 at 1 squared minus 1 cubed plus c minus 3 times 0 squared minus 0 cubed plus c. Now because I'm referring back to the same equation here, that c is the same, the negative will distribute through, those will cancel. So really what I'm left with is 3 times 1 minus 1 plus c minus 0 plus 0 minus c. The c's cancel, and we're simply left with 2. So in the first second here, this is going to go ahead 2 units here. Okay. Now b. How far does it travel in the first 2 seconds? Well, going up to here again, we're going to look at this interval right here from 0 to 2. So that distance is going to be the displacement at 2 seconds minus the displacement at 0 seconds. Okay, so here we go. So the displacement at 2 seconds is going to be 3 times 2 squared minus 2 cubed plus c minus 3 times 0 squared minus 0 cubed plus c, and I regret not giving myself enough room there. So 2 squared is 4 times 3 is 12, 2 cubed is 8, plus c minus 0 plus 0 minus c, c's cancel, and we are left with 4. Now, you've already been through the majority of this course. An obvious question at this point is, well, yeah, but did the object turn around? Like when I calculate the displacement here, has it changed the directions here at all? Maybe I'm doing this wrong because I'm blind to the fact that it changed directions. Well, let's take a look here. Where does velocity go to 0? Okay, so 6t minus 3t squared is going to equal 0. Factor out the common 3t. That's going to be 2 minus t. 2 minus t equals 0. And so this is going to be at 0 seconds or 2 seconds. So actually we're okay. So this has stayed going in the same direction until 2 seconds. Then it turned around here. So when we look at part C, where it says the object returned back to where it started when t is equal to 3, we know that it went out, okay, we went out 4, well, we know it went out 4 units in the first 2 seconds, and if it comes back, it's going to have to travel back 4 units to get there. So I'm going to guess 8. And before anybody says anything, yeah, I know it said units here, so meters. Oops.